So we're setting up this osmosis experiment. And we're using this dialysis tubing, which is actually the same material that's used for dialysis patients. So when they're undergoing dialysis, their blood is run through a machine inside this tube. The machine filters some of the toxins out of their blood. This tubing is made out of cellulose, but it has a lot of the same properties in terms of its permeability as the cell's plasma membrane. So we're using the dialysis tube in this experiment as a plasma membrane. And we're setting up essentially these little cells by opening up the dialysis tube. So I've already sealed off one end, and I've used different color string in order to sort of label which solutions I'm putting inside which cell. So pink string is going to be associated with deionized water. So I'm going to pour 20 milliliters of deionized water, approximately 20 milliliters. If we spill a little bit, that'll be okay. And then I'm going to try to get the air bubbles out, because eventually we're going to submerge these artificial cells in water, and I don't want them to float, so I want them to be totally submerged in the water. So I'm trying to get rid of all of the air, and I'm trying to fold the end over so that it doesn't leak while it's being submerged in the water. So that's probably going to be a pretty good seal. And then I'm going to tie up the other end with a string. So I'm making 3 different types of cells for this experiment. This first one with pink string is going to be the ones that contain deionized water. So I'm trying to tie this up really tightly so it doesn't leak. And then I'm going to put it in this beaker. So the second kind of cell, or artificial cell, that we're creating in this experiment is going to contain a 0.5 molar sucrose solution. So whereas the first one had pure water, this one has sugar water with a 0.5 molar concentration. So once again, I'm putting 20 milliliters, approximately 20 milliliters of the liquid inside. And then I'm folding the top of the tube, and I want to make sure, I'm going to have to let a little of the liquid out here, but that's okay. And I'm folding it a couple times so I know that it seals. And then I'm going to seal this one up with the yellow string, which is going to help me recognize that this is the tube that has the 0.5 molar sucrose solution inside. So this is when I wish I had like a third hand or something, right? Okay, so that didn't work out very well. Let me just tie this like this. Okay, and then finally, the white colored string is associated with the artificial cells that we're going to put the strongest sucrose solution inside. So the white string is associated with artificial cells that are going to contain a 1 molar sucrose solution. So once again, I'm folding it to try to seal it up. And then I'm going to tie over the fold so that it doesn't leak once we eventually submerge it in the water. And one more knot. Okay, so we've done this for actually not just the one set that you just saw me make, but we've actually made 6 different sets. I'm going to incubate 3 of those sets in warm water, and then eventually I'm going to incubate 3 of those sets in cold water. Okay, so we made all of our artificial cells filled with either deionized water, 0.5 molar sucrose, or 1 molar sucrose. The next step is to get an initial mass for each of the cells using the balance. So you're going to want to record all of these weights in grams in your data table. So I'm going to start with the cells that are eventually going to be incubated in water. That's going to be in this warm water bath. So the first cell is labeled pink, so I'm going to rinse them off first. So this first cell contains deionized water, and it is 18.49 grams. This one contains 0.5 molar sucrose, and it weighs 21.16 grams. The last one is the one that includes the stronger sucrose solution. Rinse it off and dry it off real quick. And that one is 23.15 grams. Okay, zero this out, and we'll move on to the second group. So we're replicating in this experiment so that we can work with averages instead of a single observation. So I'm going to start with our cell that contains deionized water from our second warm group, and we get 17.63 grams. Then I'll grab the yellow one, which contains the 0.5 molar sucrose, and that one weighs 21.52 grams. And then finally, we'll weigh the one that is full of the stronger sucrose solution, the 1 molar sucrose solution. And that one weighs 22.69 grams. So I'll put these back in here, and we'll move on to the third group that we're going to incubate in the warm water. So I'm just giving these guys a rinse because when we weigh them for the last time, they're going to be coming out of the deionized water that they're incubating in. So they'll be wet then, so it's good to do their initial weights wet as well, with the strings wet. Okay, so the DI water weighs 20.02 grams. Now we'll try the 0.5 molar sucrose from this third group. And that one weighs 21.06 grams. And then finally, the 1 molar sucrose cell weighs 22.83 grams. Okay, and now we'll weigh our 3 sets that we will incubate in cold water. This is the one that this one has DI water in it from set 1 cold. It weighs 21.87 grams. This one contains the 0.5 molar sucrose. It weighs 21.42 grams. And then finally, we have the cell from this set that includes the 1 molar sucrose, and it weighs 22.59 grams. Moving on to the second cold water set. Once again, I'm going to start with the one that contains the deionized water. That cell weighs 19.82 grams. And next we'll weigh the one that has the 0.5 molar sucrose solution inside. It weighs 21.68 grams. And then finally, we'll weigh the one from this set that has the stronger sucrose solution, and that one weighs 22.63 grams. Okay, and this is our last set that will be incubated in cold water. We'll start with the one that holds the deionized water. That one weighs 20.12 grams. The one filled with the 0.5 molar sucrose solution, we'll get that string inside, weighs 22.95 grams. And then finally, the last one is the one that includes the 1 molar sucrose solution in the third group that will incubate in cold water, and it weighs 22.91 grams. Okay, so all of these groups, all 6 of these groups, each containing the 3 cells that we set up, are going to be incubated in deionized water. So I'm going to pour 500 milliliters of deionized water into each of these beakers. They're all originally starting out with the same temperature water. In order to make the warm water treatments warm, we're going to put them in a hot water bath. In order to make the cold treatments cold, we're going to put them in the fridge. Put them on here. Okay, so I'm just going to go ahead and put the warm water group in the water bath. And the cold water group will go in the fridge. We're going to incubate these for 90 minutes, and then we'll see what happens. Okay, so all of these artificial cells have been incubating now for 90 minutes. These ones that I'm going to weigh first were the ones that were incubated in the warm water, in this warm water bath, and then the other 3 groups are the ones that have been incubated in the fridge. So those are the cold water treatment. So I'm going to do this just like we did the first time. So I'm going to start by just kind of drying them off on the towel and then weighing them. So this is the deionized water for warm group number 1, and it weighs 18.21 grams. Next, I'm going to grab the one that has the 0.05 molar sucrose solution. I'm going to zero this out first. This one weighs 24.48 grams after incubation. And then finally, this one feels really turgid. This is the one that had the 1 molar sucrose solution inside, and it now weighs 34.29 grams. So I'm going to set these aside. We're not going to need them anymore. And we'll move on to group 2 that was incubated in warm water. I'm going to start with the cell that contained the deionized water. That one now weighs 17.47 grams. Make sure you're recording all of this in your data table. And then we'll weigh the one that had the 0.5 molar sucrose solution. That one now weighs 24.87 grams. And then finally, I'm going to dry off the one that has the 1 molar sucrose solution. That one now weighs 33.69 grams. Set those aside, and we'll move on to group 3 that was incubated in warm water. So zero this out. I'll start by grabbing the one that has the deionized water inside. That one now weighs 19.67 grams. Next, we'll take a look at the one that has the 0.5 molar sucrose solution inside. That one now weighs 24.34 grams. And then finally, we'll reweigh the one that has the 1 molar sucrose solution inside. That one now weighs 26.20 grams. Okay, so now we'll move on to the cells that were incubated in the cold water. So we put these in the fridge. They were incubated for the same amount of time, for 90 minutes. Oh, it's chilly in there. So we'll start by zeroing the scale, and then we'll see what the final weight is for group 1 for the cell that included the deionized water. That one now weighs 21.69 grams. Next, we'll weigh the cell that has the 0.5 molar sucrose solution from this set. It now weighs 24.29 grams. And finally, we'll weigh the cell from this set that has the 1 molar sucrose solution inside. It weighs 32.64 grams. Moving on, we'll take a look at set 2 that was incubated in cold water. Starting with the one that has the deionized water, it now weighs 19.48 grams. Next, we'll take a look at the one that has the 0.5 molar sucrose solution. It now weighs 25.17 grams. And the one that has the 1 molar sucrose solution inside, which now weighs 32.10 grams. Moving on, we'll take a look at the last set that was incubated in cold water. We'll start with the one that has the deionized water inside. It now weighs 20.23 grams. This is the one that has the 0.5 molar sucrose solution inside. It now weighs 27.13 grams. And then the last one is this one that was incubated in the cold. and has the 0.1 molar sucrose solution from group 3, and it now weighs 30.87 grams. 30.87. So now your job is to use the initial and the final weights for all of these cells to make some calculations about the rate of change or the rate of osmosis in all of these different conditions. So eventually, hopefully, you'll be able to make some conclusions about how the temperature and how the internal solute concentration affects the rates of diffusion.